So the last thing in this limit chapter we're going to talk about then is continuity at a point. And what is continuity? Well, we usually think of continuous functions, right, as just functions in the xy plane that, look continuous. And that's because they are continuous. So what happens then when we run into a function, right, like the ones above here, where, the limit, like when you actually just plug in, let's say 0, 0 here, you actually don't get anything, right? You can only solve for a limit. Well, a lot of functions then are defined piecewise, and then we can then check the continuity at the certain point that's in question. So for example, let's take a look then at this following function. F of xy is equal to xy squared divided by the square root of x squared plus y squared for xy not equal to 0, 0. All right. And then we want to see, and then it's 0 if xy is equal to 0, 0. All right. So everywhere else in the xy plane, it's going to be this guy up here. And then at 0, 0, it's going to equal 0. So how do you check for continuity at the point? Well, there are three conditions. The first condition is that f of xy has to exist, all right, at the point in question. All right. The second thing is that the limit as xy approaches the point has to exist. The limit as xy approaches the point of x comma y has to exist. All right. And then the third thing is that number 1 has to equal number 2. So essentially, the function value at that point has to equal the limit at that point. Okay. So how do you show that? Well, for this, 1 is trivial, right? It's 0. So f at 0, 0 is equal to 0. Okay, that's good. All right. The second part then is we need to find the limit as xy approaches 0, 0, right? Because it only seems like the problem point is going to be 0, 0. So let's have xy approaches 0, 0, and then now we have xy squared, right, over root x squared plus y squared. Okay, what is this limit? We'll convert it into polar. Up top, I get r squared cosine theta sine theta squared, all right, and down on the bottom, I got just r, right, because it's the square root of x squared plus y squared, which is the square root of r squared, which is r, okay, and this then becomes r to the 4th cosine squared theta sine squared theta over r, and that's r cubed cosine squared theta sine squared theta, right, and this now becomes the limit as r approaches 0 because we converted it into polar. And what's this? Well, the r cubed then just kills everything else, and so this limit is 0. And from part 1 and part 2, right, the function evaluated at 0, 0 is 0, and the limit as xy approaches 0, 0 is 0, okay? And therefore, since f of 0, 0 is equal to the limit as xy approaches 0, 0 of xy squared over root x squared plus y squared, and since they're both equal to 0, then the function is continuous. All right, so that's the definition of continuous, and that's how you show continuity at a point. And we're done with 14.2, so we're going to move on to 14.3. We're actually going to take partial derivatives now. And I think, yeah, partial derivatives is 14.3. We're slowly chugging along here.